Today in this video we're gonna be talking about very simple basic things of physics that everybody knows. So today, in the first point would be the diameter. Have you ever think of the diameter? So diameter of an atom. The diameter of an atom circle diameter is 10 raised to the power minus 10 meter, and most probably it could be written as 10 raised to the power minus 11 meter. Both can be written. In some book minus 10 is given, in some book minus 11, no issue. Now we're going to talk about the diameter of nucleus. So the diameter of nucleus is 10 to the power minus 14 meter and 10 to the power minus 15 meter. These are the two possibilities that could exist. So the difference between these two diameter is that nucleus is atom's diameter is atom diameter is 1 lakh time more than nucleus diameter. The difference between them is 1 lakh times. The diameter of the circle of atom is 10 to the power minus 10 and 10 to the power minus 11. So now the question arises that helium have 2 atomic number, so it have 2 proton, 2 electron and no proton. So what could be the diameter of this? And on the other hand, we have uranium 2023 and 276 kind of, and I don't know appropriate one, but so as you can see, the electron number is 92, the proton number is 92 as well, and we minus 26 from 92, we'll get the number of neutron as well. So you can see there is a difference between neutron proton. So the question arises that does now the diameter of the circle of helium and uranium is 10 to the power minus 10? Absolutely yes, because this is a constant value. Whether the diameter, whether the atomic number is changed or atomic mass is changed, the diameter of atom circle will remain same because this is a constant value till yet. Now we are moving towards our basic terms that is rest and motion. So what do you see? Can you please tell around yourself that are you in rest? Are you at rest right now? So let's see. Can you enlist the name of the things that are in rest right now? We have our table, chair, these are in rest, right? So let's see, look up the example. What is the meaning of rest? When a body changes its position, does not changes its position according to environment, that is known as rest. So can I give you an example? For example, like a car is moving, okay, but the outside a car is moving, for example, okay, a car is moving with a speed, with acceleration and velocity. The car is moving. The people in the car is moving. The people outside the car sees that the car is motion, but the people inside the car says that they are at rest. Okay, so can you identify, are these people rest or are these people at motion? Let me give you another example. For example, now the car get punctured. Okay, car get punctured, so the car is stopped. Now the car is at rest and the people inside are moving as well, so they are at motion. Can you please tell the exact their state? Okay, for example, this earth is moving. Okay, we are at this earth, and this earth is moving around the sun. So the earth is in motion or rest? Of course, this is in rest. So at one scenario we will be at rest, and at another scenario we will be at motion. So the point would exist over here is, in this world 100% rest and motion does not exist. Got it? Does not exist. So this was the misconception. Now we're gonna see about four basic natures, four forces of nature. Are you known about it before? Let's just have a look. Basic forces of nature. So number first force is gravitational force. Let's just briefly talk about this. So the gravitational force mainly exists, and the main cause of it is masses. Okay, the range of the gravitational force is infinity. And to calculate the force of gravitational force, we require F is equal to m1 m2 over r square. The range of gravitational force is infinity. Now our second force is electromagnetic force. What is electromagnetic force and where does it exist? What's the main purpose of it? Where does it exist? It exists with charges, and the range of it is to the infinity as well. How infinity? Because if I give you the example of gravitational force, so our earth revolves around the sun due to what? Gravity. So there also the range of we can prove that the range of gravitational force is infinity, just because of earth revolve around the sun, and every planet does this. So electromagnetic force is depending on charge, and the range is infinity as well. To calculate electromagnetic force, we use this Coulomb's law, Q1 Q2 over R square, because this is the basic formula to calculate charges, the distance between two charges. Now we have third force, that is strong nuclear force. So if I could make the atom of any element, so here for example I'm gonna make the electron of hydrogen have one atomic number, helium. Let's take the example of helium. So helium have 2 protons, 2 electrons, and neutron is 0, because if we need to find the number of neutron, V minus electron with proton. V minus. So we got this. So we know that in the nucleus we have only neutron and proton, but the electrons are at the orbitals, outer shells. So here consider there are proton, and these proton have positive charge. So now this force will be acting over here. So here we know that positive charges repel each other, but the negative charges, the opposite charges, attract each other. Okay, so here you can see here are positive charges. So why they are not repelling each other? They are repelling each other, but due to the strong nuclear force, these are in the middle, in the center, in the nucleus part. That is why. So the basic purpose of this, it keeps the proton into its field. And the range, if we talk about, the range of it is 10 to the power minus 11 meter. Now we're gonna talk about weak nuclear force. So what's the purpose of weak nuclear force? So for example, here we have nucleus, and here we have electron. So the positive charge, the positive proton, and the negative electron, for example here is electron. So we're gonna see, like, now I have a question for you. Can you say that this proton will get attracted to this electron first or that electron first? Of course this electron. So due to what? Due to weak nuclear forces. And what does the weak nuclear force do? So basically the distance of the electron from the last shell, it keeps the distance from the electron to the last shell. And the range of this weak nuclear force is around about 10 minus 10 meter. So can we say this, that strong nuclear force and weak nuclear force are more weaker than these two? Now if we compare these two, so let me tell you that electric field is far more greater than 10 to the power 89 greater than gravitational force, because electric force is more greater than gravitational force. And that is the MCQ statement. Now we're gonna talk about the contact force and non-contact force. First of all, let me tell you that these all are non-contact force. Why? Let me give you the example of electromagnetic force first. For example, this is a magnet, and we know that magnet have north pole and the south pole. We tap this magnet away from another magnet. So here we have south pole and here we have north pole. So we cap this magnet without physical contact. They are coming towards each other without physical contact. So that is why these are known as non-contact forces. Electromagnetic force is non-contact forces. The best example for that is the magnets. Another example is that gravitational force. The non-contact forces are basically the forces we apply on one body to another body without physical contact. Are we doing the physical contact just because of the attraction and repulsion? just because of the attraction and repulsion, these are coming towards their opposite pole sides. So that is why we call this as a non-contact force. And another example is if I throw a ball up in the sky, it will come down. Why it will come down? Why? Did anybody throw from upside? Did anybody did? No. Just because of the gravity, it comes down, and without any physical contact, it comes down. So this is how the non-contact forces work. Let's just understand these two in deep. Now we're gonna have a look at contact force. Contact force, other name is mechanical force. So contact forces are our daily life forces we apply to everything. For example, I'm riding. This is a example of contact force. So the actual definition is that the force we apply physically are called contact force. For example, we have frictional force. We are applying it with car. It usually occurs on roads. And any mechanism that you are doing physically by your hands, by touching your body, so this is the contact force or mechanical force. So now we're gonna see the basic calculation of resultant force and net force. So for example, if a body we are like applying the force to the body from 3 sides or 4 sides. We are just applying the force from here. It's like 10 Newton. From here we are applying 5 Newton. From here we are applying 20 Newton. From here we are applying 60 Newton. So the basic answer for the resultant force is we need to add all these forces. So when we add all these forces, we get a result 95. Now this is a bit different. So now we're gonna talk about net force. It is basically written as like this. So you can see that this force and this force is opposite. We are applying it from this side, and there we are applying from this side. So first of all, we minus 10 from 5, we get answer 5. Then you can see these two forces are also here, and we are applying them on from the opposite side. So we're gonna apply 60 minus 20. We got answer 40. Now we're gonna add these two more, and we got 45. So this is what? This is net force, and this is resultant. Resultant is quite easy, and net force we need to do some kind of sums. So we got the answer. These all gonna be coming in vector topic. These are the basics first. So now we're gonna see some conditions. For example, if net force is 0, what if the net force is 0? So the body will be in rest. First of all, the body will be in rest or uniform velocity. When these two conditions will be occurring, so the body will come in equilibrium. We can also say that. And can I say this? And can I say if the net force is 50, can you find out the net force applied to the body is 50? Can you find out in which direction this body will go? From here. So for that, we have to find the angle, and the formula of finding angle is 10 inverse Fy upon Fx. Now let me just draw a simple chart for it. So we know that the circle is of 360, this is of 90, this is of 180, this is of I guess 260, 270, sorry, and this is of 360. This is x positive, x negative, y positive, y negative. So if the answer, if the calculation comes in 90, so the body will be going over here in this direction. If 180, the body will be going here. So in this way we're gonna find out the angle of the body, direction of the body, and these were a few points.